Hi, this is Justin Mansell from Active Optical Systems, and this is a video today that shows users how to use a deformable mirror to impose different phases on a beam of light. So this is the result of a run I just did to impose different Zernike terms on, and all we're doing here is commanding a deformable mirror to different shapes in an open loop fashion and measuring what we're seeing on a wavefront sensor. So today we will walk through how to accomplish this using the AOS software. First thing I'm going to do though is stop the demo and start the software again so that you can see this all from scratch. Okay, so now I've restarted the AOS software, and the first thing I'm going to do is select a camera. So I'll go here to this G30B wavefront sensor I have set up and grab one frame from that. And so we have some static aberration relative to some arbitrary reference kind of thing going on here. I'm going to create a new reference. What I'm seeing here is that I've got a lot of subapertures here, or at least a few of them, that are pretty weak. And so there's a couple of ways of trying to fix that. One is to go into here and make that number larger and create a new reference. There we go, that worked. For the individual ones that I still don't like, see, that one's really weak, and these ones at the bottom are hanging off, and these kind of things. You can add masks, so right click and drag, and I can say delete inside rectangle. There we go, those are gone, and I just don't like that individual one here. I'm going to say delete that AOI. And so it shows me that it's deleted that AOI and this around here. So now I'm going to go in and hit single acquire, and I'm measuring noise in the room. So I've got some random noise things going on here, and it's pretty low amplitude, 35 nanometers. The results tab is now showing me that I'm about 9 nanometers RMS. So now I'm going to go in and start the adaptive optics portion. So I'm launching adaptive optics here. First thing I need to do adaptive optics is get a drive electronics set up. So let me go to configuration. It's a network drive electronics that I'm working with today. Hit device settings. This is the correct IP, but I'm going to click find devices to show you this piece of it. It will go off and use a UDP broadcast to find it. I can say use this device, and that will copy the IP address that it found for that one into here, and I can say connect, and now I'm connected to it. I need to load now a DM file, so I can do that a variety of places, but let me just go to the main DM control tab and hit load, and I'll have to navigate to that directory. Okay, so I've navigated to that directory, found the DM that I'm working with. I'm going to say OK to that. So this is a 32 actuator DM. First thing I'm going to do is increment it up to, let's just do a 10% bias for today. And I'm checking my settings here to make sure that they're reasonable. I'm going to limit myself to 25% stroke and 20% interactuator stroke with a 6mm interactuator spacing. You can check that by looking here and taking a look at the difference in spacing there in the x-axis. And this happens to be, I think, approximately 6. Let me look again, 28-ish to 33-ish. It's about right. Maybe it's a 5, so let's change this to a 5mm spacing. Okay, so now that I have that set up, I can re-baseline here. So let me do a single acquire. Biasing the DM, since the gains on the actuators are slightly different, gives me slightly different results here. So I'm just going to arbitrarily say that this is my new flat. You can do all of this with an absolute reference. I'm just not going to do that today. If I say recenter spots, that means that I'm copying the current centroid locations to the references. So I say OK to that, and now I'm measuring the noise in the room in the system again. So to prove that this is actually working with the DM here, I'll hit that, and let me go here, change this to increment voltage, change this to 1% or something like that, and I'll just hit an actuator, and there it is, an actuator showing up. So now I can decrement that due to the hysteresis. It won't quite go away, but it's pretty close to 0 now. It's showing up there in the background and the noise. Okay, so now I can stop acquisition, and I think we're ready to measure a poke matrix. So I'm going to do a 5% poke let's make it a 9% poke. Why not? 10% bias, and hit go. And it's going to go through here and quickly measure the poke. You can see that happening there. You'll also see this bar advancing. And the first thing I'd like to look at is, did all of the influence functions measure? There were a couple of them that were a little low, but it seems like that's going to be okay. This is my poke matrix. That looks really good. My control matrix, of course, this is over-resolved, so it doesn't quite look like a typical free geometry. I can look at the modes here. I've got one low-gain mode here that I've removed. I almost always remove one mode from the system, and I think we're ready to go. So I'll minimize that just to get it out of the way. And I think we're now ready to actually implement the AO offsets feature. So you can close the AO loop here, but since I don't have any offsets, I can't quite see these shapes take place. But if I go in here and I load offsets, I can go back to my Zernike ones. And if I then go by date modified, I can go in here and select the files that I've created that are CSV files that are, in this case, these are 64 by 64 phase samples. And so it's just an array of those phase samples with a 1000 nanometer scaling factor on them. So I'll say open to those. They show up now in this list. I can change the magnitude of those here if I want to. When I'm doing this, and I can also change the number of frames per offset that I'm going to do. I'm going to leave that at 50 for now. Now if I go into the AO side, I can say use offsets. This is already set correctly to 400 iterations. The system will go through and calculate, oh, you have 8 phase screens that you're trying to create and 50 iterations per phase screen, and do the math for you. But because I've run this before, it remembered that's what I did last time. So I can now say ARM, and that will get the system ready to go. And so now we're ready to do adaptive optics and trigger. And the only thing that you'll see changing are the voltages on the DM. So you can see here it's counting iterations over here, and as it's doing that, it's warping the DM into different terms. And if you look carefully, that's, for example, a coma term. You can see some of these Zernike terms showing up, of course, at very low resolution on the DM surface, and then it's done. What it then did was save out 2 different sets of files. So give me a sec here, I'll navigate. So now we can see these 2 sets of files that were created. I'll just sort by date modified. These are the files that were my input files. I've created a little show interpolation script that shows me the interpolated values. But what it's done is it's taken these 64 by 64 phase terms and interpolated that onto this 20 by 22 grid here. And it shows me as outputs .dm files and offset files. The offset files contain information about the interpolation. So we can open up one of those. I'll just use Notepad++ for this. And it shows me the index, the x index, the y index, the x slope, the y slope, and the phase for each one of these. Okay, so that's what's in these offset files. In the .dm files is your typical .dm. This is all documented in the manuals, but it's a CSV type file with the actuator locations and the bounding boxes and things like that. But this is the voltages that converged on line, in this case 34 here. Okay, great. So now I have a bunch of .dm files that I can write out and create those phase terms. So let me go back to the AOS software and go 0 all, increment all, bring it back up to 10%. I'm just left clicking to bring that up. And then if I go to dynamics, I can say start here. These are the .dm files that I just created. So this is Zernike numbers 3 to 10. So I'll say open to that, and then go in and say continuous acquire. And what it's doing is every second putting out a new one of those results onto the DM. And I can see that happening with the wavefront sensor in the system. So that's a little video on how to use the new AO offsets feature inside the AOS software, and you can use that to put whatever phase screen you want onto a DM and impose that, of course, onto the beam of light. And you can do this for creating Zernike terms, of course, but you can also do it for creating atmospheric phase terms and aerooptic phase terms and these kinds of things as well. If you have any questions, don't hesitate to contact us, and thank you for listening.